Hello friends. So today we'll see how we can solve the product of array except self without using extra space complexity. Like we'll use answer array, but rather than the answer vector, we can say we're not using extra prefix multiplication and suffix multiplication. So let's see how we can do that. Okay, let me take you to the screen. Yeah. Now, so question we know that it says ki product of array except self. It means we want a product which do not include the element at that index. That for that each index we need a product we where that element itself do not get included. So for that what we had did first in first video, like say in first video, what we will do now that we'll use answer array like answer vector as our prefix multiplication. First we'll do that, then we'll take one right multiplication variable and we'll update that and we'll multiply that right multiplication with our answer. That first our answer was prefix multiplication and then we are multiplying with the right multiplication, so ultimately answer will be the same and we'll see how it works. So take this example 1 2 3 4 here only, like yeah. For that, what I said, we will use our answer vector as our prefix multiplication. So for that, when we go for the first index, it answer is one only. Cause for first index there is no one at left, and its answer is one. And for second, like first, like for zeroth index, it's one. Then for the first index will be answer at I minus 1 into nums at I minus 1. We don't want to include itself, so we'll multiply with num at I minus 1. So for 1, it will be 1 into 1 and it will be 1 only. Then for second index, it will be 1 into 2. Nums at I minus 1 is 1 and nums at I minus 1 means this one is 1 and answer at I minus 1 is num this 1 and answer at I minus 1 is 2 and 2 into 1 is 2, and then we'll go for the third index. For third index nums at I minus 1 is 3 and answer at I minus 1 is 2, so 3 into 2 is 6. So first our answer vector will work as prefix multiplication, and then we'll take one right multiplication array. Right multiplication is equal to 1 and we'll traverse it reverse, and for that let's say okay, we'll go at last, and for the last number it's right, there is no one at right, so right multiplication will be 1 and right multiplication into answer at I, as answer at I is a prefix multiplication, so answer at I into right multiplication will give us 6, and then we'll go for last second. For that we'll do nums at I plus 1 into right multiplication. So right nums at I plus 1 is 4 and my right multiplication, sorry nums at sorry what I want key for that answer at I index, left multiplication into right multiplication. My answer I itself a left multiplication and right multiplication is right multiplication that we have took a variable. So answer at that index is 2 and right multiplication will update at every iteration. And for first one, that when we assign 6 at that time, right multiplication into right multiplication is equal to right multiplication into nums at I. So for that it will be 4. Like after when we assign 6 at that time, the right multiplication will be 4, and then we'll go for last second index. For last second index, answer at that last second, which is 2, into right multiplication, which is 8. So then here the answer will be 8, and my right multiplication will be right multiplication into nums at that index. Nums at that index is 3, so into 3, which is equal to 12. Then we'll go for the last third, which is 1. The answer at that one is 1, and 1 into 12, which is 12. So here we'll get 12 only. Then we'll our right multiplication will be right multiplication into nums at that index, which is 2, and it will be 24. Then we'll go and we'll 24 into answer at that index, which is 1. Then answer will be 24, and that's what we have here. So let's see how we can code it. So for that we'll need to take first size. We'll store size in n is equals to nums dot size. Then our answer vector int answer. Our answer will be for n. Let's take all the zeros now. And for left multiplication, like for the first index there is no one at left, so answer at that 0 will be 1. As we are treating our answer as our prefix multiplication array, so yeah, for now its answer at 0 is equals to 1. And let's traverse I is equals to 1. And yeah, there will always will be the one element, because they have told us ki nums at length always will be greater than or equal to 2. So nums at 0 will not be like, it won't say ki n is less, n is equals to 0. N will be always greater than 0, so nums at 0 is equals to 1. It won't give us error. So I is equals to 1. I is less than n, I plus plus. For that, our answer will be answer at that index is equals to answer at that previous one and nums at that previous one. Nums at the previous one, because we don't want to include the number at that index. So yeah, this will form our prefix multiplication array. Now we want, like, we can't treat it as the right multiplication, so we'll take one variable like right multiplication, which is equals to 1. Like for the right multiplication we are traversing from the last, so for the last element we don't have the element after the last element, so we'll take the right multiplication is equals to 1 for the last element. Like we'll see how we can do it. Like for the last element, for the last element right multiplication always will 1. So yeah, let's traverse it reverse. I is equals to n minus 1, I greater than equal to 0, and I minus minus. We need to reduce it. So answer at that index should be cross equals to, like, answer at that index is equals to answer at that I can write it. I can, like, answer at that index is a prefix multiplication cross right multiplication, and my right multiplication will get update to, let me take like this now, right multiplication into nums at that index, and likewise it's done, and return the answer array. Run it, and yeah, it get accepted, submitted, done. So time complexity for this will be big of n, and space complexity for this will be big of n, like not big one n, like space complexity and including the answer vector also. And we have used just extra one, right, that this variable as extra space. Yeah, so total space complexity will be big of n, and time complexity will be big of n, because we have used for loops here. Like here big of n, here big of n, which is basically two big of n plus big of 2n, but generally we take big of n. So that's it for all guys for today, and yeah, I hope you like video. So bye.